Hello everyone, welcome back to our Algebra 2 class. Today we are going to continue our conversation about the trigonometry function. And today we finally can introduce what are these functions. And also today, after today's lesson, you will see why we mentioned so many things about the angles, unit circles before, because we are going to use them to help us to define sine or cosine function, which is, the two types of the trigonometric function. So to start our conversation, let's have a quick warm-up. In Algebra 1 or in geometry you learned before, you probably heard the word SOHCAHTOA. You probably still remember this is actually the way we memorize the definition of sine or definition of cosine. So to prepare the lesson today, we need to quickly review how do we define sine or cosine in the right triangle. Remember, if you still remember in geometry or in algebra 1, to define sine or cosine, the very first thing we need to use the angle, any angle we are given, the acute angle to define the opposite side, which is right across the angle. This is opposite side. And also the one next to the angle is called an adjacent side. And also this one, the longest one, or we say the opposite side of 90 degrees, this is always hypotenuse. Right, that's always, opposite and adjacent always changing based on the position of the angle. But hypotenuse is always the longest side, or you can see is the opposite side of 90 degrees. So the way we define sine or cosine is always, we write sine as sin, but we do not call this as sin. It's still sine. And also we follow the angle. In this case, we just use a Greek letter to name it. Sine theta is opposite over hypotenuse. So that's where come SOHCAHTOA, this sine is opposite over hypotenuse. For cosine, the definition for cosine in the right triangle is adjacent over hypotenuse. That's where ka coming from. CAH meaning cosine is defined as adjacent over hypotenuse. Okay, so that's just quick review regarding something we learned before about sine and cosine. And if you heard this word before, SOHCAHTOA, this is actually coming from their definitions. And today we only focus on the sine cosine, so we just skip the TOA part. So with this definition, then our question is, as we see in the previous lesson, we know the angle code can go beyond the right triangle, right? Can go beyond like even 200, 300, even just more than that. And we can also define negative angle. Then for those kind of angles, how do we define sine or cosine? And then we need to use the standard position of the angle, which involve with circles or unit circle. So let's see how do we define them. So if we have a random angle, as you can see, we can always draw the random angle for its standard position, right? So for example, we call rotation diagram. We always start with initial rate, which is the positive side of x-axis. And then I can just random define. For example, let me define this angle. So this angle is going to be, let's say, we can call beta. It's still a Greek letter. We just name this angle as beta. So how do I define this one? As you can see, I draw a circle here. I draw a random circle here. And this random circle, the center is in the center in the origin of the coordinate plane, which is 0, 0. So the circle has a equation which is x squared plus y squared equal to r squared. The r here is a radius of the circle. As you can see, this terminal ray here is, the terminal ray is going to intersect with the circle at point x and y, right? Just because, just like a very similar way when we introduce unit circle, but I'm going to extend this one in a random circle. So And then how do we define sine? Since if I, draw a right triangle here, like this, then I know the vertical distance is going to be y. That's just how we read the coordinates of the point, right? And also the horizontal distance of this piece is going to be x. So sine beta, and according to the definition, the in right triangle, we know sine is always follow opposite over hypotenuse. And in this case, hypotenuse, as you can see, happen to be our radius. So in this case, the sine beta, again, I can use any letter to name this angle. I just use, Greek letter to name this, is defined as the opposite side, which is y, over hypotenuse r. And that's it. That's our definition for sine as a random angle. And you may wonder, then what if this angle, go beyond like a second quadrant or third quadrant? Let's just, name it. So for example, I'm continue rotating. I'm going to rotating here, right? I'm going to rotating here. So this is going to be a new angle. Let's, name this as theta. It's, way much wider angle. Same thing, the initial ray, no, the terminal ray of this theta is going to intersect that circle at another point, which is xy, right? So same thing, I just, even this is, a random position, I'm still gonna use, I still define this as sine theta is the y over r. So the y over r here, I actually use this little right triangle here. So I actually use a reference angle of the theta to help us to define this way. But I just use the original definition to go extended to the different position of the angle. So this is going to be our definition for sine. It's always y over r. The r is coming from the radius of this random circle. Now, let's go back to check how do we define cosine. So same thing, I'm going to, let's use a different color. I'm going to draw a random angle, which is initial ray starting with positive side of x-axis. And then this is terminal ray, same thing. This circle is x squared plus y squared equal to r squared. And the terminal ray intersect with a circle at x, y. So similar, I'm going to draw a right triangle to help me to define the cosine. I'm going to call this angle as alpha. Again, this is just another Greek letter. You probably heard this letter before. So according to cosine, as we defined before, is adjacent side over hypotenuse. Let's just quickly label what is adjacent, what is opposite, what is hypotenuse. Hypotenuse, as you can see, this is actually our radius because any position of the point, the distance between the center to the point is a radius. And this piece is x because this is how we read the coordinates. And the vertical piece is going to be y. So sine alpha, I'm going to write this. So cosine, right? So cosine, sorry. Cosine alpha, this is how we write the Greek letter alpha. This is just angle, nothing special for that. Is equal to adjacent over hypotenuse. So it's going to be x over r. See? This is just how we use coordinates to help us to define sine or cosine. So let's quickly write down the final conclusion of their definition. So sine, if you're given random circle, random angle here, we define this as y over r. And for cosine, we have the definition for x over r. The r is the radius of that circle. So this is just how we define for a random angle. And we use their rotation diagram to help us to figure out the definition. So some student might say, but you keep talking unit circle before, then why do we use unit circle? That's going to be our next part. So instead of using random circle, as we can see x squared plus y squared equal to r squared, what if I use unit circle? So do not forget, the unit circle, the very special part is the equation of unit circle is x squared plus y squared equal to 1. In this case, if you can see, the r becomes 1, right? So that's the most important part. So if we just still have a random angle here, I still label this x, y. And you know, the very special part is this radius is 1. So sine theta will be equal to, okay, y over r, but r is what? Is 1. So it's very simple, change it as y, right? So this is how do we define this in unit circle. And same thing for cosine. Still, this coordinates intersect as, you know, x and y. And again, unit circle, why is it special? The radius is 1. So cosine theta, according to the definition, is going to be x over r, but r is 1. So I can just define this as this. So the good part of the unit circle, I can still use a random, I can still use original definition, but the very, very luckily, I can just simply say sine theta is y, cosine theta is x. That only works for unit circle because the radius is 1. I don't need to worry about the radius. That's exactly we mentioned before the unit circle, because I can just use unit circle to define this angle so easily, define this trigonometry function. Okay, so after all the preparation, we know sine theta is y, cosine theta is x. According to unit circle, in the next video, we are going to do several practice to understand what is going on and how do we find the values for sine and cosine for different angles. And after those practices, you will have way much better understanding to connect all the pieces together, so you can see why we press so many lessons to today to, you know, prepare the lesson today. Thank you so much for watching this video, and see you soon in the next video so we can practice several questions together.